Good evening, everyone. Welcome to what, if you are in the Monday, Wednesday section, is our last official class, though you are, of course, welcome to come again tomorrow night if you have more questions. My plan tonight is to focus on your questions, and if there aren't questions, I'll go ahead and provide my own questions for you to work on just as practice. But I'm happy to talk about anything. As I mentioned in the email I sent you, I really encourage you to also look at your old exams, just to give you some extra things to look at to make sure you feel very well prepared for this upcoming final, which is coming ever closer. I also wanted to say the last sample final is going to get posted at some point later tonight. I need to wait on a couple things before I can go ahead and post that, but it should be up before I go to bed tonight, so you should have all of tomorrow to look at it, and you're welcome to ask questions about it tomorrow in office hours or tomorrow evening in our last class. All right, any questions about any of that before I go over this? YouTube warned me that I don't have audio. Can people actually hear me? I think they should be able to. Question mark? Excellent. Great. All right. So let's do this this sample question first, and then I'll open it up to anything that you wish to ask. Okay. So we want to know what point on this graph has a tan line that is parallel to this line. Okay. And so remember, parallel means same slope. And so in particular, we want slope to be equal to 2. Okay. So really, this question, after you sort of look at it, it's really asking, where does the tangent line have slope 2? And so that's really asking, where is the derivative 2? So I want to take the derivative here. And then I want to find out where that's 2. So it would be x is 5. The x is 5 halves. And so this point will be 5 halves, comma, and then I need to put this 5 halves back into the original equation. So that will give me 25 over 4, y of 5 halves, I should say, minus 3 times 5 halves, plus 2. So a little bit of fraction math. This is 25 over 4. Minus, this is 30 over 4, plus this is 8 over 4, and so this is 3/4. Okay, so you've seen a bunch of variations of this pop up on the homework and the sample finals that I have given you so far, but this is an important question, or an important style of question to keep in mind, and it's also easy to get tricked by this -1 here, because the -1 here is actually completely extraneous information. Okay, it could have been literally any number, and the solution we would have used would be exactly the same. because in order to be parallel to this line, I just need to look at the M. I don't need to look at the B piece at all. Okay, so with that, I'll open it up to questions from sample tests, past exams, homeworks, just any concepts you want to go over, anything of that sort. We're a pretty small group tonight because a lot of people took the final today, so you should have plenty of time to get any questions that you have answered. Okay, well, while you think if there's any questions, I'll put up a sample question and give you a few minutes to practice doing this, and then we can go over it and make sure we're comfortable with this kind of question. Okay, let's start going over this. So, first of all, this is definitely a closed interval method question. Hey, this is what the closed interval method exists to do, to decide what the biggest and smallest outputs of a function are in a closed interval. And so to use the closed interval method, the first thing I need to do is find the critical numbers of this function, for which I need the derivative. Okay, so if I write this down following this formula, I will get a prime b minus AB prime all divided by B squared. And I want to note, still probably about a quarter of people on tests are doing the quotient rule backwards. So remember, the quotient rule is this. Or AB prime. That part doesn't matter. But a lot of people have been swapping these two terms. And if you swap those two terms, then you get the negative of the derivative. And so if you're doing something like a first derivative test question or a closed interval method question, then you may well get exactly the opposite of the answer if you do that. So if you had a note on your if you had a note on your test 6 that said something like, this was a backwards quotient rule, that's what I'm telling you. You need to make sure that your A is the numerator, the B is the denominator, and then it has to go in this order. Okay, so continuing onward, I want to find the critical number, so I really only care about the numerator because I want to know when this derivative is equal to 0. And so to find that, I'm going to go ahead and simplify this. Minus 2x squared minus 2x equals 0. This will be minus x squared minus 2x plus 3 equals 0. I can go ahead and negate everything. And so this will be x plus 3 times x minus 1 is 0, which will give me x is minus 3 and x is 1 as my critical numbers. Okay. And people are actually really good at not getting fooled by this on the test. Minus 3 is outside the interval, so we throw that one away. So then, continuing to follow the closed interval method procedure, I need to calculate f of minus 1, f of 1, and f of 2. Okay. F of minus 1 happens to be 0, because the numerator ends up being 0 up here as soon as I plug in minus 1. F of 1 is 2 over 4, which is a half. And f of 2 is 3 over 7. So the largest of these is a half. And the smallest of these is 0. Some people were still not quite answering these questions in the correct way. They were giving me the x's or were giving me points or whatever. Note when it's asking for min and max values, this word values means outputs. So I'm specifically looking for the things that come out of the f. Okay. Any questions about that? Okay, well, let's practice also a first derivative test question just to make sure we have all of that shored up. I'll give you a couple minutes again. Alrighty, let's go over this question. I would say overall, on the test, there were a lot more people who got confused about the first derivative test and how to write up solutions and what exactly an answer looks like than there were on the closed interval method. So I want to make sure we go over this carefully. So by coincidence, this is also a quotient rule question. So just as before, I need to find the critical numbers before I can go anywhere else. So f prime of x here is going to work out to be 4x minus 5 times e to the x minus 2x squared minus 5x minus 1 times e to the x, all divided by e to the x squared. Okay. And I want to note there's an e to the x in both terms in the numerator, as well as two of them in the denominator, so I can go ahead and cancel these e to the x's with one of the e to the x's in the denominator. Plus 9x minus 4 divided by e to the x. And because this is a first derivative test question, unlike the previous one, where I immediately said, okay, I'm going to grab the numerator and just set that equal to 0, here I'm deliberately keeping the entire function, and I'm simplifying it without setting it equal to anything, because I want the derivative simplified as much as possible for what I'm going to be doing. Okay, so now let's factor the numerator here. So minus 4 minus 1. That'll work out as a factorization. And so this is my simplified form of the derivative that I'm going to work with for the rest of the problem. Okay. Now, I can go ahead and set the numerator here equal to 0 to find my critical numbers. And that will give me that my critical numbers here are x equals a half and x equals 4. So I go ahead and put these numbers on my number line. So keep in mind, if you are given a question that specifically mentions the first derivative test, and your answer does not include a number line and some test points, something has gone horribly wrong. And so a lot of people on some of the first derivative test questions just gave me a list of the critical points, or maybe something from the graph. Make sure you're giving me a number line and filling out all of this information like we've been talking about. So I need to pick my test points. So I'll pick 0 and 1 and 5. And this is where it helps that I have a simplified version of the derivative to plug these things into. So when I go to find f prime of 0, it will be minus 1 times minus 4 divided by 1. So that will work out. Sorry, I ran off the bottom of the page there. That will work out to be minus 4, which is minus 4. And so it is negative. When I then go ahead and find f prime of 1, that will end up being minus, and then 1 times minus 3 over e, which will happen to be 3 over e. Okay, and the only thing I care about here is that that is positive. Okay. And again, this is just much easier to plug stuff into because I factored it and wrote it out like that than it would be if I was trying to plug this back into the original form of the derivative. Okay. Next, I need to plug in 5. So there is f prime of 5. And so this is going to be minus 9 times 1 divided by e to the 5th, which is minus 9 over e to the 5th, and that is negative. Okay, so that is our derivative profile. But we then go ahead and translate this derivative profile down to information about the original function. Okay, where we get that this is decreasing, increasing, and decreasing. Okay. And so we get really two pieces of information out of this. So first of all, I want to note we learn that this is a local min because of this shape. And this is a local max, again, because of the shape. Okay. And I want to reiterate, when I say something like classify the critical points, this is what I'm looking for, is for you to find the critical numbers, which we did up there, and then identify whether they're local mins or local maxes or kinks. But we also here learned the information that this particular question happened to ask for, namely what intervals this function's increasing and decreasing on. So it is increasing on the interval 1/2 to 4, and it is decreasing on the interval -infinity to 1/2, and the interval 4 to infinity. Again, go ahead and ask any questions about this in the chat if you have them, but I'll go ahead and put up another question. And so I wanted to do one example of each thing from this past test in case you had any questions about that. But now I'll try and jump back into some of the much older stuff. So I'll give you a minute with this limit question. Okay, Anna, let's look at that. So, is your question, let me just clarify, is your question, why does it always seem that positive infinity is on the right side and negative infinity is on the left side when I write these down? Yeah, so whenever we write down an interval, by convention, we always write the smaller number on the left and the bigger number on the right. So I would write the interval of numbers between 1/2 and 4 as 1/2 4 rather than as 4 1/2, for example. If I was writing down an open interval, I would not write it in that order. Okay. People would probably understand what you meant if you said, okay, the open interval 4 1/2, probably they know you mean the numbers between 1/2 and 4, but just usually we write the smaller number on the left. Okay. So when I'm describing a range of inputs here, I go, okay, I'm describing the range of inputs that starts at a half and ends at 4. I'll write that in the order 1/2, 4. Well, by virtue of where plus infinity is on the number line, when I'm describing something that includes as one of the ends plus infinity, it's always going to be the further right entry. And so it's always going to start at a number and end at infinity. And the same is true, but backwards, for minus infinity. Namely, minus infinity is always going to be the furthest left piece. And so as long as we're honoring this convention, that we're always starting on the left and going to the right, we'll always have minus infinity on the left when it shows up. Does that make sense and answer your question? Okay. Let's talk about this limit. So, ultimately, we probably remember the key here when doing this kind of limit is that we want to ultimately find a place to cancel this x minus 3. But currently I don't have such a place, so I need to go ahead and try and rewrite this. Okay, so I will multiply by 1 over x minus 3 instead of dividing by x minus 3. And then I will put these two over a common denominator, which will end up being 3x. And so the 3 needs an x. Sorry, the 3 needs a 3. Sorry, I tricked myself by writing this in the other order. That needs a 3 minus, and then this needs a second x. And so this will turn into, the limit as x goes to 3 of, and then it will be 9 minus x squared divided by 3x times x minus 3. Now we have to factor the numerator, which will factor as 3 minus x times 3 plus x divided by 3x over x minus 3. And the trick here, if you can call it that, is that I need to factor a minus 1 out of this term, because if I do, it will make it match this term. So on the next line, this becomes the limit as x goes to 3 of minus x minus 3 times x plus 3 divided by 3x times x minus 3. And all I did here was to pull a minus out of both of these terms. And I did that because now, when you look at that, there's an x minus 3 and an x minus 3, so I can cancel them out. And now once I've done that, now I can actually calculate the limit, which will work out to be minus 6 divided by 9, which is minus 2/3. Okay, so speaking of limits, let's go ahead and do a using the limit definition of a derivative to find the derivative question, because I know we have not done one of those in a bit. I'll give you a couple minutes to look at that, and then we'll do it together. Okay, let's go over this question. Oh, there's a question. Yes, we can do that. That can be the next question. I have some of those set aside, in fact. So here we need to write down our 2 points. So the first point is 3, 4. And then we bump that point a smidge to the right. Like that. And it'll probably make my life a little bit easier if I simplify this first. So this will be 3 plus h, comma, square root of 16 minus 6h minus h squared. Okay, so these are my 2 points. Again, this second point is just the first point bumped the tiniest bit to the right. But I'm going to write down the average rate of change between these 2 points. And that will work out to be square root of 16 minus 6h minus h squared minus 4 divided by h. And so, as often comes up when there are fractions and square roots floating about, the thing I want to do is multiply by the conjugate. So the numerator here works out pretty nicely. So it'll work out to be 16 minus 6h minus h squared minus 16. And the denominator will be h times this square root. Okay, so the 16s drop out. And so I can take an h out of each term in the numerator, because now there is an h in every term in the numerator. And so this will work out to be minus 6 minus h divided by this square root bit. Okay. And so once you've gotten here, all that you need to do to finish the problem is take a limit. So f prime of 3. And in the case of derivatives, that limit is always the limit as h goes to 0 of this thing. Okay, and that will work out to be, in this case, minus 6 over 8, or minus 3/4. And so that is the value of the derivative. I should note, by the way, there are really two flavors of these use the limit definition of a derivative questions that are likely to show up on the final. There's this one where it's something with a square root, in which case it's important to note there is no other way that we know to take the derivative of this. Our formulas don't let us take the derivative of square root of a function as it currently stands. You'll have to take 141 if you want that. So the limit definition is actually the only way we know to get this derivative calculated. Okay. The other version that shows up sometimes, though, is that sometimes it'll be something like, here's a fraction, take the derivative. For that, we actually know the quotient rule. So even if the question asks for the limit definition, you could do the limit definition and then check your answer with the quotient rule and make sure you've gotten it right. Okay. Anyway, always be looking for ways to check your answer, because, of course, you want the questions you turn in on the final to be right, because the final is worth 20% of your grade, plus it can replace the lowest test grade, so it can improve your grade by quite a bit. Okay, so next, we have a request for a question about sketching the derivative. So here's a graph. Let's sketch the derivative of this. And I'll go ahead and just label these outside parts are parabolas. And the inside parts here are lines. So as you sketch this graph, keep in mind what the derivative of a line and what the derivative of a parabola looks like. Okay, so let's look at this. And so here are the two key things to remember. The derivative of a parabola is always going to be a straight line. So that's the first piece. And the second piece is that the derivative of a line is just the slope. Okay. In other words, whenever you take the derivative of a line in a graph, it is always going to look horizontal in the derivative. Okay. So all of that being said, let's try and sketch this derivative. Okay. And I want to mark off a few things. So any part where the shape of the graph changes, so here it switches from a parabola to a line, I'm going to mark that coming down here. Here it switches from a decreasing line to an increasing line. And here it switches from a line back to a parabola. So I'm going to draw those. And I'm also going to identify any of these places where the tangent line is horizontal, these places that we would now call critical points. And I'm going to follow those down to the graph below. Okay. Now, those spots are very nice because they give me points on the derivative right away. Namely, these are the spots where the derivative is 0. So I can fill in that point is on my graph, and that point is on my graph of my derivative. Okay. So now I want to look at, okay, what happens with this parabola piece? I know the derivative is a line, but there are lots of lines. Does it slant that way? Or does it slant that way? Or is it flat? Okay. Well, I can figure that out by figuring out where the derivative is positive or negative. In particular, the derivative is negative on this side and positive on this side. So if I look just at this piece, the derivative has to look something like this. Okay. Straight line, positive slope. And it's a positive slope because on this side the derivative has to be positive, on this side it has to be negative. Now we're on to this line piece. This line has positive slope, and so as noted, the derivative has to be a horizontal line, but it has to be a horizontal line at a positive spot. So it's going to look something like that. And note, this is going to force there to be a jump in the graph of the derivative, which means I need to put an open circle there on both sides to communicate that. Now I'm over to this line segment. And this line segment, you'll notice now has negative slope. And so we need to jump down over to here. Still horizontal. Okay, again, that's a jump in the graph. So that's going to force there to be these holes in the graph like that. And now I know this last piece has to pass through this dot. And I have to decide, again, does the graph of the derivative slant like that? Or does it slant like this? And if it does slant like this, does it match up perfectly with this point? Or does it end up a little above it or a little below it? Okay. Fortunately, in this case, it's actually the opposite, because on this side, this thing is increasing, so the derivative is positive. So it ends up looking something like this, so we don't have to think about exactly how it matches up. Okay, and we again get these holes like that. So that is what our derivative looks like. Okay, since people asked about that, are there any more questions about this style of question or any other styles of questions people want me to do in the last bit of class today? I can pick myself, but if you have any requests, I take requests. Okay, well, I will put up a tangent line question. Oh, sorry. I just see a question popping up. I don't know what you mean by the derivative graphs not matching. Do you mean the fact that there's jumps in the graph like this? There have to be. If your answer to this question does not have these gaps, then your answer to this question is wrong. Your answer must have these sorts of gaps that are indicating that there's a point in the graph where the function shifts sharply from increasing to decreasing. And so that's why the derivative jumps from being positive to being negative, rather than being a smooth transition. Okay. I'm going to put up a tangent line question because I noticed in the sample finals I skimmed over, there are a lot of people who've sort of forgotten some of the key steps about doing tangent lines. So I want to wrap up with one of these, but I'll give you a couple minutes. Okay, let's do this. And so here's my first point, and this is the thing I saw a number of people not get quite right on the sample final when I looked at it, which is that your answer to a tangent line question has to be a line. which means it has to look like y equals mx plus b, with m and b both being numbers. Okay. So in particular, when I skimmed some of the sample finals, I saw some people who had written things like this. And I don't have to look at the problem at all to know that this can't be the tangent line to anything, because this 3/2 tells me it's not a line. And the way you end up with tangent lines that aren't lines is that you forget a key piece of the derivative. Namely, the derivative itself is not the slope of the tangent line. The derivative knows how to find the slope of the tangent line. So this will show up as we do this question. Okay, so the first thing I need here is the point, which is going to be 64, comma, and then f of 64, which is going to be 2 times 8 plus 3 times 4. Which sounds like 28. Okay, so that is our point. Then I'm going to need the derivative. So the derivative here will be 2 times 1 over 2 root x plus 3 times 1/3 times x to the minus 2/3 power. Okay. And the way I know this is the derivative of cube root of x is that cube root of x, remember, is the same thing as x to the 1/3. So I just use the power rule. Okay. So this works out to be x to the minus 1/2 plus x to the minus 2/3. So here's the key step we have to remember. This is not the slope of the tangent line. In order to get the slope of the tangent line, I have to actually plug in the matching x, which is to say I have to plug in x is 64. Okay. So the slope is f prime of 64, which in this case is 1/8 plus 1/16, which is 3/16. Quick reminder, how did I get that this was 1/8 and 1/16? X to the minus 1/2 would be 1 over the square root of x. The square root of 64 is 8, so it's 1/8. X to the minus 2/3 is 1 over x to the 2/3. And remember that x to the 2/3 is the same thing as the cube root of x squared. And the cube root of, in this case, 64 is 4. So the cube root squared is 16. Okay. So I am looking for the line that has slope 3/16 and passes through the point 64/28. And so I set this up as I'm used to, which is to say, okay, it's going to look like y is 3/16 x plus b. I'm going to plug in this point, which is going to give me 28 equals 3/16 times 64 plus b. Okay. Fortunately, this works out nicely. So this is 28 equals 12 plus b. So b is 16. And then that tells me that the equation of my tangent line is y is 3/16 x plus 16. And that is the answer to my question. Okay. Notice 3/16 is a number, 16 is a number. This is just x to the first power. All right. We're going to wrap up there for tonight. Have a wonderful evening, and I will see some of you tomorrow either in office hours or in the review session tomorrow night. So remember, review session tomorrow night at 6 p.m. Office hours tomorrow at 10 a.m. There's still math clinic tonight, so if you want to get one last bit of help, you can go do that now. But that's all for now. Have a good night. Happy to help. Let me know if there's anything else I can do.